Before time began, there was no silence, for even silence belongs to something. There was no darkness, because darkness is measured against light. There was no emptiness, because emptiness requires space in which to exist. There was only nothing, a void beyond imagination. No place, no distance, no before, no after, a reality without a stage, without actors, without even the laws that could one day allow a stage to exist. And then, against all reason, against all possibility, from this ocean of absolute nothingness, the universe appeared. A fire ignited, without a spark, a storm without a sky, an existence without a cause. This is the paradox that haunts science and philosophy alike. How could everything, stars, galaxies, life itself, erupt when there was nothing to ignite it? Human thought is built upon chains of cause and effect. Every fire must have a match, every seed must have a soil, every sound must have a vibration. Yet the greatest story of all begins without one. Did the laws of physics create themselves in that instant? Did quantum uncertainty allow a universe to flicker into being? Or does the very question, what was before, collapse when time itself had not yet begun? Tonight, we step into the abyss before the first second. We will follow the trail of light left behind by the birth of time itself, searching for an answer to the question that may never truly be answered. How did the universe begin, when nothing existed to begin it? Since the first fires burned in human hands, there has been one question that has never released its grip on the human spirit. Where did everything come from? In the silence of ancient nights, beneath skies unpolluted by city lights, people tilted their faces toward the vast canopy of stars. What they saw was both beautiful and unbearable, an ocean of light that stretched into forever, and yet left no trace of its origin. To explain this overwhelming mystery, civilizations gave birth to stories. The Babylonians imagined the universe forged from the carcass of a defeated god, her body split apart to become the heavens and the earth. The Greeks envisioned chaos, a gaping void from which Gaia and the first deities emerged. In India, hymns spoke of an eternal cosmic breath, the pulse of creation and dissolution, expanding and contracting like the inhale and exhale of the divine. The Norse told of a yawning abyss called Ginnungagap, where the fires of Muspelheim met the ice of Niflheim, giving rise to all that is. Each myth was an attempt to soothe the unanswerable, to cast the infinite into human language, yet buried within them all was the same instinct. The idea that the world could not simply appear, it must be ignited, shaped, or commanded into existence. Something must come before, to set the first cause into motion. This instinct, the demand for a cause, is not only cultural, it is psychological. The human mind is wired to think in terms of chains. A dropped stone falls because of gravity. Fire burns because a match is struck. The seed grows because it is watered by the rains. Centuries of survival conditioned thought itself to seek the link between action and result. Cause and effect became the rhythm by which reason marched forward. Without it, the world collapses into chaos, a place where nothing makes sense, and where thought itself unravels. But if the mind is bound by causality, the cosmos itself may not be. And this is where the story of science begins to diverge from the ancient myths. For while myths explain the universe by embedding it within an endless cycle of causes, science eventually dared to suggest something more radical. Perhaps the universe does not require a cause in the way we imagine. The first steps toward this thought were cautious. In the 17th century, philosophers like Descartes wondered whether existence itself required a prime mover, an initial being whose perfection justified the existence of everything else. Centuries earlier, Aristotle had named this figure the unmoved mover, the being that causes motion without being moved itself. For thousands of years, this seemed the only logical possibility. Yet, as the scientific revolution unfolded, the framework of nature began to change. The telescope extended the eye. The microscope unveiled hidden worlds. The equations of Newton revealed a clockwork universe, governed not by gods, but by laws. The cosmos was no longer explained through divine battles or infinite cycles, but by the geometry of motion and the elegance of mathematics. Still, even in Newton's mechanical universe, causality reigned supreme. Every force had its equal and opposite counterpart. Every motion was the consequence of another. But the ultimate question remained untouched. Where did the first motion come from? Who wound the spring of the cosmic clock? Newton himself, uneasy with infinity, suggested that perhaps God occasionally intervened to keep the machine aligned. It was a gesture to mystery rather than a resolution. By the 19th century, as science grew bolder, a new possibility emerged. Could the universe be eternal? If it had no beginning, then no first cause was required. The cosmos might stretch infinitely backward, its existence as natural and unquestionable as the air we breathe. For many, this was a comforting thought. If the universe had always been here, then there was no paradox to resolve. But this too was fragile comfort. For even the idea of an eternal cosmos was built on assumptions that would soon collapse under the weight of new discoveries. As the 20th century dawned, the foundations of human thought trembled. Albert Einstein, working in the quiet halls of the Swiss Patent Office, wrote equations that would forever transform the human view of reality. His general theory of relativity did more than describe gravity. It rewrote the nature of space and time themselves. The universe, Einstein's equations whispered, could not remain static. Space was restless. It could stretch or contract, bend or ripple. To Einstein, this was an unwelcome conclusion. He added a term, a cosmological constant, to force the universe into stability. But the equations themselves resisted. They wanted motion. Soon after, astronomers would lift their telescopes and confirm what the mathematics suggested. The universe was expanding, rushing apart like a great tide pulling galaxies with it. The dream of an eternal, unchanging cosmos was shattered. Suddenly, the question of beginnings was back. Sharper, more urgent, and more unsettling than ever before. For if the universe was expanding, it must once have been smaller. If it was smaller, it must have had a starting point. And if it had a starting point, the ancient question returned. What ignited the first spark? But here lies the true depth of the paradox. To imagine the beginning of the universe is not merely to imagine a spark. It is to imagine the birth of time itself. The very stage upon which causes and effects unfold was itself part of the creation. Asking what came before becomes a meaningless question, for before had no existence. And so the human mind, bound to chains of cause and effect, stares into the abyss of a truth it can hardly bear. The universe itself may not have a cause in any form we recognize. It may have emerged from nothing, or from principles beyond our comprehension. The first question, the question of origins, is not only about the birth of stars and galaxies. It is about the birth of causality itself. If every story begins with a spark, what story can we tell when the spark itself is absent? If every flame is born from fire, how do we speak of a fire that burned into being without a match? This is the weight of the mystery. The scale of the question is not simply cosmic, it is existential. It challenges not only science, but thought itself. For to answer it, humanity must confront the possibility that the most fundamental belief we hold, that everything has a reason, may itself be an illusion. And yet, in this illusion, perhaps lies the most extraordinary truth, that reality itself is the reason. That existence needs no anchor outside of itself. A universe without cause is a universe that is simply here. At the dawn of the 20th century, the universe was imagined as eternal, vast and unchanging. Astronomers believed the heavens were fixed, a grand celestial stage upon which stars shone with timeless permanence. The universe was thought to be steady, infinite in age, infinite in extent, without beginning and without end. But beneath this stillness, the mathematics of a quiet man in Switzerland told another story. In 1915, Albert Einstein unveiled his general theory of relativity. It was not simply a theory of gravity, it was a revolution of perspective. No longer was space an empty backdrop, a silent container for matter. In Einstein's equations, space itself was dynamic, alive. It could bend, ripple, expand, or contract, shaped by the matter and energy it contained. Yet this revelation was so unsettling that even Einstein himself recoiled. The mathematics suggested that the universe could not remain perfectly static, that it must be in motion. But the idea of a changing universe seemed absurd, even heretical. to the scientific imagination of the time. To preserve the eternal heavens, Einstein introduced what he called the cosmological constant, a mathematical term designed to hold the universe in balance, to keep it frozen in place. Still, the equations whispered otherwise, and the universe itself would not remain silent. In 1929, at the Mount Wilson Observatory in California, Edwin Hubble aimed the largest telescope of his age toward the night sky. What he discovered would forever transform the human view of existence. Hubble studied faint smudges of light, once thought to be mere clouds within our own galaxy. Through careful observation, he proved they were galaxies in their own right. Island universes. Vast star cities far beyond the Milky Way. But the true shock came when he measured their motion. Using the subtle stretching of light, he found that these galaxies were not still. They were fleeing, rushing away from one another at astonishing speeds. And the farther away a galaxy was, the faster it seemed to recede. The meaning was unavoidable. The universe itself was expanding. Space was stretching like an inflating fabric, carrying galaxies outward in all directions. This discovery struck like thunder. The eternal, unchanging cosmos of ancient thought was gone. The universe had a history. It was not static but evolving, not timeless but moving through ages of birth and transformation. If galaxies were rushing apart today, it meant they must once have been closer together. Trace that motion backward, and there must have been a time when everything was gathered in a single, unimaginable point. A Catholic priest and physicist, Georges Lemaître, took the daring step of naming this origin. He called it the primeval atom, a cosmic egg that burst in the first moment of creation. In his vision, the universe began not as a vast expanse, but as a single seed of unimaginable density, containing within it all that would ever be. Every star, every galaxy, every atom, every thought. The idea was bold, unsettling, and resisted by many. Even Einstein at first dismissed it, but the evidence began to mount. Then, in 1965, by accident more than by design, humanity stumbled upon a voice from the beginning. Arno, Penzias, and Robert Wilson, working with a radio antenna in New Jersey, detected a faint, persistent hiss of microwave radiation. At first, they suspected pigeons nesting in the device. They cleaned the machinery, drove the birds away, but the hiss remained. What they had found was the afterglow of the universe itself, the cosmic microwave background. It was the cooled echo of the primordial fireball, the radiation left over from when the universe was only 380,000 years old. In that moment, the cosmos had cooled enough for atoms to form, allowing light to travel freely for the first time. And that light still drifts through space, washing over the Earth from every direction, a silent testimony to the universe's fiery birth. This discovery transformed speculation into evidence. The Big Bang was no longer theory alone. It had left its signature, a relic heat etched into the very fabric of the cosmos. To this day, sensitive instruments like the Planck satellite trace the subtle variations in that background glow, mapping the tiny ripples of density that would one day become galaxies and stars. Yet even as the evidence pointed clearly to a beginning, the cause remained hidden. The Big Bang explained that the universe expanded from an initial state, but not what triggered it, or why it happened at all. The primeval atom was described, but its origin was not. For scientists and philosophers alike, the discovery was both triumph and torment. Humanity had traced back to the first light, had uncovered the relic echo of creation. But the most haunting question lingered. What lay before? And here the paradox deepened. To ask what came before the Big Bang may be to ask a question without meaning. For the Big Bang was not an explosion in space. It was the creation of space itself. Before it, there was no before. Time itself began with that first instant. The discovery phase of cosmology revealed more than evidence. It revealed the limits of human language, of human thought. The universe had a beginning. Yes, but that beginning defied the very categories by which the mind makes sense of existence. In the great sweep of cosmic history, this was the moment when science first touched the veil. Humanity had uncovered the traces of the first light, had seen the afterglow of the primordial fire. And yet, the question that echoed from the ancients remained, sharper now than ever. How could such a universe ignite when no spark was there to light it? The discovery of the expanding cosmos and the echo of its beginning was not an answer, but an invitation. An invitation to journey deeper into the abyss, to search not only for what the universe is, but for why it exists at all. The phrase Big Bang suggests something familiar. An explosion, a detonation, the sudden blaze of fire into an already existing space. But this is a deception of language, an image that soothes the imagination by making the impossible seem ordinary. The Big Bang was not an explosion in space, it was the creation of space itself. In that first instant, time itself unfurled. Before this moment, there was no stage, no distance, no before upon which an earlier cause could act. The universe was not born into emptiness. Emptiness was born with the universe. This realization struck like a philosophical thunderbolt. For if time itself began with the Big Bang, then the question what came before collapses under its own weight. There was no before. The question itself dissolves, like a shadow where no light exists. Yet to the human mind, conditioned by chains of cause and effect, this answer feels unbearable. Every fire must be lit, every seed must be planted, every story must have a first page. To accept a beginning without a cause is to step into a void where reason falters. Albert Einstein himself was unsettled by this abyss. His general theory of relativity revealed that matter and energy bend space-time, and that under certain conditions this curvature collapses into a singularity, a point where density becomes infinite and the equations of physics break down. For Einstein, this was not just mathematically strange, it was philosophically intolerable. Nature, he believed, could not permit infinities. Singularities were failures, artifacts of an incomplete theory. But the equations were merciless, and others dared to follow them further. In the 1960s, two young physicists, Stephen Hawking in Cambridge and Roger Penrose in London, confronted the singularity head-on through elegant mathematics. They proved that singularities were not avoidable accidents of Einstein's equations, but inevitable features. If general relativity is correct, then the universe must have begun in a singularity, a point where space, time, matter, and energy were compressed into nothing more than pure geometry, and where all known physics ceases to function. Their theorems left little room for escape. If relativity holds, then the universe has a beginning, a boundary, a point at which the familiar laws of nature dissolve into silence. This was the true scientific shock. Not simply that the universe began, but that it began in a way utterly incompatible with reason itself. A singularity is not just small, it is undefined. It is not a particle, not a dot, not even a place. It is the breakdown of the very concepts of place and time. At the singularity, the fabric of reality folds inward until it tears, and beyond that tear lies nothing. To imagine this is to stand at the edge of thought itself. What does nothing mean when not even space exists to contain it? Not the empty silence of a desert, not the black stillness of outer space, but the complete absence of being. No distance, no duration, no void. Here language falters, for human language was built inside time, inside cause, inside matter. When these are removed, words fail. The mind gropes for analogies and finds none. And yet, science was forced to accept this impossible truth, that the greatest story of all begins where understanding cannot follow. The implications rippled through physics and philosophy alike. If the universe has a boundary in time, then causality itself may not stretch beyond it. The chain of reasons may terminate, not in a higher cause, but in a silence that allows no further explanation. For centuries, thinkers had argued for an eternal universe precisely to avoid this nightmare. An eternal cosmos required no beginning, no first cause. Now the evidence pointed elsewhere. The universe did not appear eternal. It appeared finite in age, with a beginning written into the very structure of space and time. It was as though a curtain had been lifted to reveal that behind the stage of existence, there is no machinery, no hidden mechanism, no secret hand, only the abyss of nothingness. Some scientists resisted, even as late as the mid-20th century. Alternatives were proposed. The steady-state model, in which new matter was continuously created as the universe expanded, keeping it eternal. Others hoped that future physics might smooth away the singularity, revealing a gentler beginning hidden beneath. But the singularity theorems remained relentless and stark, and observations from the recession of galaxies to the cosmic microwave background reinforced the conclusion. The universe had not always existed. It had come into being. What does it mean for existence to erupt from non-existence? This is not simply a question of science, but of metaphysics. If space and time themselves are emergent, then the very categories of before and after, cause and effect, may be features of the universe, not conditions beyond it. It is as if the laws of physics are written on the parchment of the universe itself, and at the beginning, the parchment is blank. For many, this idea is unsettling, even terrifying. For if the universe had no cause, then reason itself is unmoored. If the chain of causes terminates in nothing, then human thought, built upon causality, is left grasping at emptiness. And yet, others find in this same mystery a kind of awe. For a causeless beginning means that existence itself is fundamental. It requires no justification beyond its own reality. The universe simply is. Stephen Hawking once wrote that asking what came before the Big Bang is like asking what lies north of the North Pole. The question presumes a context that does not exist. Time itself was born in that first moment. The search for before is the search for a direction that vanishes as we walk toward it. The shock of nothing is not just a scientific discovery. It is a mirror held to human thought. It shows us the boundaries of our imagination, the limits of our categories, the fragility of our need for causes, and it forces a haunting possibility that the origin of all things lies not in some grand cause, not in a divine spark, not in a hidden mechanism waiting to be discovered, but in the absence of all of these. The universe may be the ultimate magic trick, a flame that burns without fuel, a story that writes itself without a pen, a symphony that begins without a first note. This is the paradox at the heart of cosmology. The Big Bang gave science its greatest triumph, a beginning traced back to the first instant of time, and in the same breath, it gave philosophy its greatest wound, the realization that this beginning cannot be explained by the logic of causes. The universe erupted into being not from something, but from the impossibility of nothing. And so the human journey, standing here on a small planet adrift among galaxies, confronts the abyss. To understand creation is not only to measure galaxies and light, it is to wrestle with the silence where answers collapse. The scientific shock is not just that the universe began. It is that it began without a cause that we can recognize. A causeless dawn, a boundary beyond thought, where time itself first learned to tick. The discovery that the universe had a beginning did not end the mystery. It deepened it. For if existence could emerge from nothing, then the question sharpened. What kind of nothing could give rise to everything? In the realm of everyday life, nothingness is simple. An empty room, a silent pause, a void without content. But physics revealed a far stranger truth. The void, when examined at its most fundamental level, is not empty at all. This is the lesson of quantum mechanics, the theory born in the early 20th century to explain the strange behavior of atoms and light. At quantum scales, emptiness trembles with uncertainty. Particles flicker into being and vanish again, like sparks in a storm too brief for the eye to see. Energy itself fluctuates, restless and irreducible. This quantum foam is not a poetic metaphor, but a measured reality. In laboratories, particle accelerators such as CERN's Large Hadron Collider reveal this hidden turbulence. When high-energy collisions split matter apart, they uncover particles emerging seemingly from nowhere, created from the energy of the vacuum itself. The void is not still. It is seething, fertile, alive. And from this strange sea of fluctuations, physicists began to imagine the seeds of universes. In the early 1980s, Alan Guth, a young physicist wrestling with problems in cosmology, proposed an audacious idea. The infant universe, he suggested, underwent a brief but staggering expansion, a phase called cosmic inflation. In less than a trillionth of a second, the universe ballooned faster than the speed of light, smoothing out irregularities, stretching space to near uniformity, and setting the stage for galaxies to form. Inflation solved puzzles that had troubled cosmology. Why is the universe so smooth on large scales, with galaxies scattered like gentle ripples rather than violent storms? Why is the cosmic microwave background so uniform in every direction, as though space itself had been ironed flat? Inflation provided the answer. The rapid swelling of space erased irregularities, leaving behind the even canvas we see today. But inflation was not merely a solution. It was a revelation. For if such expansion could be driven by quantum fields, then perhaps the universe itself had blossomed from a fluctuation in the vacuum, a trembling of nothing that gave rise to everything. Still, deeper layers of mystery remained. What was this inflationary field? Why did it surge and then decay, releasing its energy into particles, light, and matter? The mechanism remains uncertain. Some describe it as a false vacuum, a temporary state of the quantum field that collapsed into the true vacuum, unleashing the Big Bang. Others envision more exotic landscapes, where entire universes are bubbles budding off from a vast quantum sea. The Planck epoch, the first 10-4310, minus 43, 1043 seconds, is the veil through which these questions pass. In that instant, the universe was so dense, so energetic, that gravity itself fused with the quantum. All known physics collapses here. General relativity, which governs the large-scale cosmos, and quantum mechanics, which rules the small, cannot both apply. A theory of quantum gravity, still unfinished, is required to see through this fog. And yet, even if the Planck epoch remains hidden, the universe left behind traces of its earliest instance. Instruments like the Wilkinson microwave and a Sotheby probe WMAP, and the Planck satellite have mapped the faint irregularities in the cosmic microwave background. Patterns only a few millionths of a degree in temperature. These tiny fluctuations are not random noise. They are the fingerprints of quantum seeds, magnified by inflation to cosmic scales. From these seeds, structure grew. Slightly denser regions drew matter inward, collapsing into galaxies, stars, and planets. Slightly thinner regions stretched into the voids that now span millions of light years. Every star that shines, every world that forms, every human who looks up at the night sky, all trace their existence to those first quantum ripples. This revelation is staggering, for it means that the vast architecture of the cosmos, clusters of galaxies spread across billions of light years, may be the magnified imprint of subatomic uncertainty. The deepest law of existence may be that reality itself emerges from the restless jitter of nothingness. Yet here again, the paradox deepens. If the universe is born from quantum fluctuation, then what set the stage for that fluctuation? What laws governed the vacuum before space and time existed? To speak of before the Big Bang is perhaps meaningless, and yet the human mind insists upon asking. If the vacuum is fertile, what gave rise to the vacuum? If laws of physics sculpted reality, what wrote those laws? Inflation, for all its triumphs, does not resolve the origin. It moves the question one step deeper, from the spark to the field, from the fire to the vacuum. And inflation itself opens doorways more unsettling still. Some models suggest that once inflation begins, it may never entirely end. In certain regions of the quantum field, inflation continues indefinitely, spawning bubble universes in an endless froth. Our universe may be only one bubble among countless others, born in a sea of eternal inflation. If so, then the birth of universes may be a natural process, not a singular event. The cosmos may not be one story, but a vast library of stories, each universe a page written upon the fabric of possibility. And yet, the paradox remains. What ignited the first page? What breath gave rise to the library itself? The deeper science looks, the more profound the questions become. Each discovery expands knowledge, but also magnifies mystery. The void is no longer nothing, but a storm of possibilities. The first light is no longer the absolute beginning, but the flowering of seeds planted in shadows we cannot see. The deeper investigation reveals not answers, but the strange fertility of nothingness, a vacuum that births particles, a fluctuation that inflates into galaxies, a silence that hums with potential. For humanity, this is both unsettling and wondrous. To imagine that the stars and planets, the oceans and mountains, every life and thought, all trace back to fluctuations in the fabric of the void. That the universe is, in some sense, a magnified quantum dream. And yet, even as instruments map the afterglow of creation, even as equations describe the tremble of the vacuum, the first question remains untouched. What allowed the void to tremble at all? Why should the vacuum exist, with laws to govern it, rather than nothing at all? The deeper we peer into the seeds of creation, the more we encounter the limits of human thought. The Planck epoch remains hidden, the vacuum unexplained, the laws themselves mysterious. And in this silence, the paradox of beginnings lingers. The universe is written in ripples, yes, but who, or what, first stirred the sea? The search for origins had carried humanity from myth to mathematics, from telescopes to satellites, from whispers of ancient gods to the faint afterglow of the Big Bang. With every discovery, the outlines of the universe's beginning came into sharper focus. Yet with each answer, the question itself seemed to grow deeper, darker, more impossible. For if inflation explained the smoothness of the cosmos, if quantum fluctuations accounted for the seeds of galaxies, then another question rose immediately. What caused inflation itself to begin? Alan Guth's inflationary model was elegant, powerful, and remarkably successful at matching observation. But it left behind a silence. Inflation requires a field, a false vacuum state, a reservoir of energy from which the universe could surge outward. But where did this field come from? What set it into motion? The mystery of beginnings did not dissolve with inflation. It sharpened into a paradox. Physicists began to explore the implications. In some versions of the theory, once inflation starts, it never completely ends. Certain regions of the quantum field decay into ordinary space, forming universes like ours, while other regions continue inflating. This process repeats endlessly, like a bubbling pot where new universes are born in expanding bubbles of spacetime. This is the unsettling vision of eternal inflation. If true, our universe is not unique. It is one bubble among countless others in an infinite cosmic sea. Each bubble may have different properties, different laws of physics, different constants, different stories written into their fabric. Some may ignite stars, others may collapse into darkness. Still others may shimmer with dimensions we cannot imagine. The idea is breathtaking. It shifts the question of origin from the singular to the plural, from the universe to a universe. Our cosmos becomes one page in a library without end. But here the paradox grows sharper still. For if universes are born endlessly, what ignited the process in the first place? If inflation is eternal, what was the spark that began inflation itself? In trying to escape the singularity, cosmology seemed to have discovered an infinite regress, a chain of universes without origin, a cycle without a first link. But infinity is no answer. It is a deferral. The first cause remains hidden, only pushed further from view. This deepening paradox haunts modern cosmology. Each attempt to explain the beginning requires a prior condition, a prior field, a prior law. Yet each condition raises the same question: why this, and not nothing? Consider the possibility of false vacuum decay. The vacuum of space may not be perfectly stable. It may be a temporary state, destined to collapse into a lower energy form. If so, the universe itself is precarious, a bubble that could one day vanish in an instant, replaced by a new reality. Indeed, some theorists suggest that our own universe may have been born in just such a collapse, a higher vacuum state decaying, releasing its energy to ignite the Big Bang. But this vision, too, sharpens the paradox. If our universe came from the decay of another vacuum, then where did that vacuum come from? If every collapse requires a prior state, then the chain extends backward without end. It is a haunting vision. Universes blinking into existence, expanding, evolving, collapsing, replaced by others. An eternal froth of beginnings and endings. Yet none of these cycles answer the simplest question of all. What lit the first spark? The paradox deepens further when we confront the multiverse itself. If inflation generates countless universes, then every possible configuration of physics may exist somewhere. But why should there be a multiverse at all? Why should the laws that allow inflation themselves exist? To say the multiverse explains our beginning is to shift the question to a higher level, to ask not why our universe, but why any universe at all. This is the point at which science begins to dissolve into philosophy. For the more deeply we peer into the origin, the more we confront questions that seem unanswerable. If time began with the Big Bang, then causality cannot reach beyond it. If inflation birthed the cosmos, then something must have birthed inflation. If the multiverse exists, then something must have written the rules by which the multiverse itself unfolds. And so the scientist and the philosopher meet at the same precipice. The paradox of nothing. It is a paradox because every answer leads to a deeper question. If the universe began from a singularity, what caused the singularity? If it arose from a quantum fluctuation, what permitted the fluctuation? If from inflation, what ignited inflation? If from a multiverse, why does the multiverse exist? If from a vacuum, why is there a vacuum at all? Each answer collapses into the same silence. This is the deepening paradox of cosmology. The more knowledge expands, the more profound the mystery becomes. The boundaries of science advance, but the origin recedes, always just beyond reach, always hidden behind the veil of nothing. For human thought, this paradox is both unsettling and beautiful. It reveals the limits of reason, the fragility of cause, the strangeness of existence itself. The universe, in all its galaxies and stars, its oceans and mountains, its minds and questions, may rest upon a foundation that has no foundation, a fire that burns without fuel, a story that begins without a page. And so the mystery escalates. From the singularity to inflation, from the inflation to the multiverse, from the multiverse to the vacuum itself. Every answer deepens the question. Every light reveals a deeper shadow. The cosmos becomes a hall of mirrors, reflecting origins into infinity, while the true spark remains hidden in the darkness. It is here, in this paradox, that science confronts its most profound challenge. Not a lack of evidence, nor a failure of theory, but the possibility that the origin of all things lies outside the reach of thought itself. For how does one ignite a fire in a void with no match? The paradox of beginnings weighs heavily on science. If the Big Bang was the birth of space and time, then what could it mean to speak of before? If inflation sculpted the cosmos, then what ignited inflation itself? If a multiverse exists, what gave rise to the multiverse? In the face of these questions, scientists turn not only to evidence but to speculation. And in these speculations, the boundaries of science and philosophy blur, offering glimpses of possibilities that stretch imagination to its breaking point. One of the most radical ideas is that the universe did not require a cause at all. It tunneled into existence through the laws of quantum mechanics. In the quantum world, particles can appear in places they should never reach, slipping through barriers as though probability itself rewrites reality. This process, called quantum tunneling, is well observed in laboratories. It powers nuclear fusion in the hearts of stars, allowing particles to merge despite their repelling forces. What if, some physicists ask, the universe itself tunneled into existence? Alexander Vilenkin proposed such a scenario. The universe may have spontaneously arisen from a state of nothing, where no space, no time, and no matter existed. Only the potential for existence, described by quantum law. In this picture, nothing is not the absence of everything. It is a stage with no actors, but still governed by rules, quantum laws, that permit fluctuations, probabilities, the possibility of tunneling. The universe might then be a quantum leap from non-existence into existence, a fluctuation that did not collapse, but expanded into everything. This idea is bold, unsettling, and controversial, for it suggests that the ultimate foundation of reality may not be reason or cause, but probability itself. Another vision emerged from Stephen Hawking and James Hartle, the no-boundary proposal. In their model, the beginning of the universe is not a singular point of infinite density. Instead, time itself is curved, like the surface of the Earth. As one walks north, there is no sharp edge at the pole, only a smooth rounding where direction ceases to make sense. Similarly, as we trace back toward the Big Bang, time may curve smoothly, erasing the notion of a before. In this view, the universe is finite, but unbounded. It has no beginning in the ordinary sense, no sharp moment of creation, no first tick of the clock. Time simply becomes space-like at the origin, a dimension without cause. The no-boundary proposal reframes the question entirely. If there is no boundary in time, then the demand for a cause disappears. The universe requires no ignition because it never had a singular beginning. It simply is, a self-contained whole. For Hawking, this idea carried profound philosophical weight. What place, then, for a creator, he once asked. If the universe requires no boundary, it requires no cause beyond itself. Inflation, too, offers speculative answers. If inflation is eternal, then universes may be budding endlessly from the quantum field. In this picture, the multiverse is not a hypothesis, but a consequence. Universes appear as naturally as bubbles in boiling water. Some cosmologists argue that in such a multiverse, the question of why our universe is replaced by why not. If infinitely many universes exist, then all possibilities are realized somewhere. Our universe, with its specific laws and constants, is simply one realization in the vast landscape. This reasoning brushes against the anthropic principle, the idea that the universe appears fine-tuned for life, because only in such a universe could life arise to ask the question. Out of countless universes, we inhabit the one that permits us to exist. Yet even eternal inflation does not silence the paradox, for it leaves behind the higher question. Why should there be inflation at all? Why should quantum fields exist to generate universes instead of nothing? Others imagine the cosmos not as a single beginning, but as an eternal cycle. In cyclic models, the universe expands, ages, collapses, and is reborn in an endless rhythm, like a phoenix rising from its ashes. Such visions echo ancient myths, where time itself was cyclical and creation had no absolute beginning. Modern versions, such as the ekpyrotic model, emerge from string theory, proposing that universes are born from the collision of higher dimensional brains, vast membranes in a space beyond our perception. Each collision ignites a new Big Bang, followed by expansion, cooling, and eventual collapse, only for the cycle to begin again. If true, causality is preserved in an eternal rhythm. No first spark is needed, for the cycle itself is the spark. But here, too, mystery lingers. Even a cycle requires laws to govern it, dimensions to host it, conditions to sustain it. Why should the cycle exist, rather than nothing? String theory, the ambitious attempt to unify all forces of nature, introduces yet another possibility. In its framework, the fundamental constituents of reality are not particles but vibrating strings, tiny filaments whose oscillations define the properties of matter and energy. String theory predicts extra dimensions beyond the familiar three of space and one of time. In these higher dimensional spaces, vast brains, multidimensional surfaces, may float like sheets. When two brains collide, the energy released could ignite a universe. Our Big Bang, in this picture, may have been the fire sparked by such a collision. It is an audacious vision, casting the origin of our universe as one event in a higher dimensional arena we cannot directly see. Yet, as with other theories, it does not silence the deepest question, for one must ask, why are there brains? Why is there a higher dimensional space for them to drift within? Finally, there is the vast and controversial vision known as the multiverse landscape. In this view, the laws of physics themselves may not be unique. String theory predicts an enormous number of possible configurations, as many as 1,050,010, 510,500 different vacuum states, each with its own laws, constants, and dimensions. If each configuration can give rise to a universe, then reality is not one cosmos, but a landscape of universes, a boundless diversity where every possibility is realized. The multiverse, if it exists, would explain why our universe appears so finely tuned. Out of an unimaginable number of universes, most may be barren, sterile, unfit for life. But a few, by chance, will have the delicate balance that permits galaxies, stars, planets, and minds. We live in one of those few, not by design, but by survival. Yet the landscape too cannot silence the haunting refrain. Why anything at all? Even if infinite universes exist, even if all possibilities are realized, why should there be possibility itself? Why not nothing? In the end, each speculation expands knowledge, but also deepens mystery. Quantum tunneling suggests a universe from probability, but leaves unanswered the origin of quantum law. The no-boundary proposal erases beginnings, but cannot explain why such a timeless geometry exists. Inflation, cycles, brains, and multiverses shift the question from one frame to another, but never erase the silence at its heart. The paradox remains: existence instead of non-existence, something instead of nothing. And perhaps this is the ultimate boundary. For science, no less than philosophy, may discover that the deepest question cannot be answered, only transformed. The theories shimmer like windows, each offering a glimpse, each incomplete. None can banish the abyss entirely. None can silence the mystery of the causeless spark. For perhaps the universe does not require a cause. Perhaps it is the cause. Perhaps existence is the foundation, not built upon anything deeper, not waiting for a reason beyond itself. If so, then the question itself becomes poetry. The spark that ignites without a match. The fire that burns because it is fire. The cosmos, in all its strangeness, may be the ultimate answer. Not why, but because it is. The mystery of beginnings is not only a question of philosophy. It is a challenge to science itself. To stand at the edge of thought and declare that the universe began without a cause is not enough. Humanity hungers for evidence, for traces, for signs written in the stars. And so, across the last century, our species has built instruments of astonishing power. Machines and telescopes that stretch perception across billions of years. Detectors that listen to the vibrations of space-time itself, and computers that attempt to replay the opening scenes of creation. Each is an extension of human curiosity, a tool forged to reach into the abyss and touch the echoes of the first spark. At the heart of this quest stands the James Webb Space Telescope. Launched into the cold silence beyond the Earth's shadow, it drifts at the L2 point. 1,000,000 miles from home, its golden mirrors unfolding like the petals of a cosmic flower. JWST is humanity's most powerful eye into the past. Its instruments capture infrared light, the stretched, reddened glow of galaxies born when the universe was young. Every photon it collects has traveled across billions of years, carrying with it a fragment of ancient history. Already, Webb has peered farther than any telescope before it. It has revealed galaxies so old, so luminous, that they strained the limits of cosmological models. Some appeared only a few 100 million years after the Big Bang, a time when, by current theory, the cosmos should have been too young, too chaotic, to form such grandeur. These observations force questions upon science. Are our models of galaxy formation incomplete? Or are we glimpsing signs that the early universe unfolded in ways stranger than expected? Each image from Webb is not only a portrait of ancient light, but a mirror reflecting the unfinished story of cosmic origins. If telescopes look outward and backward in time, particle accelerators look inward, probing the smallest scales, where the secrets of creation may still reside. At CERN, beneath the French-Swiss border, lies the Large Hadron Collider, a ring of superconducting magnets, 27 kilometers long. Within it, protons are accelerated to near the speed of light and smashed together with energies not seen since the first trillionths of a second after the Big Bang. These collisions recreate conditions of the early universe. For a fleeting instant, temperatures soar to unimaginable levels. Particles emerge and decay, and the vacuum itself reveals its hidden energy. The discovery of the Higgs boson in 2012 was one such revelation. The Higgs field, spread invisibly across space, gives mass to particles, allowing matter to exist. Without it, no atoms, no stars, no life. Its detection confirmed that the vacuum itself is not empty but structured, a field woven into the fabric of reality. Yet the Higgs also sharpened the mystery. For calculations suggest that the Higgs field may not be perfectly stable. Our universe could be balanced on a knife's edge, a false vacuum that may one day collapse into a lower energy state, erasing everything in an instant. Particle physics thus does more than explain the present. It questions the future. It reveals a universe that may be temporary, precarious, and haunted by instability. Beyond light and particles lies another messenger: the vibrations of space-time itself. In 2015, the LIGO Observatory detected gravitational waves for the first time, ripples in the fabric of reality caused by colliding black holes. These waves traveled across the cosmos for over 1 billion years. silent until they shook the mirrors of detectors on Earth. Since then, a new era has begun. Gravitational wave astronomy listens not to light, but to the trembling of space. And some hope that these waves may carry whispers from the birth of time itself. If cosmic inflation occurred, it should have left an imprint, a background of primordial gravitational waves, echoes of the universe's first instant of expansion. Detecting such a signal would be a direct fingerprint of inflation, a confirmation that the cosmos truly blossomed from a quantum seed. The search is ongoing. Instruments like LIGO, Virgo, CAGRA, and the future space-based detector LISA push ever closer to the sensitivity required. To hear such a signal would be to catch the vibrations of creation itself, the tremors of the first moment when nothing gave way to everything. Where observation falters, simulation takes over. Supercomputers, with their oceans of processors, attempt to replay the birth of the universe. They trace particles through time, evolve galaxies from quantum fluctuations, and test how different laws might shape different realities. Simulations have shown how tiny ripples in the cosmic microwave background grew into vast clusters of galaxies, how dark matter sculpted the large-scale web of the cosmos, and how subtle changes in fundamental constants could have led to barren universes instead of fertile ones. These virtual universes are laboratories of imagination, testing grounds for speculation. They cannot reveal the first cause, but they can show what kinds of universes are possible, what structures emerge, and how fragile the conditions of our existence truly are. The search is far from over. New instruments are being prepared, each aimed deeper into the abyss. The Simons Observatory in Chile and the proposed CMBs for experiment will map the cosmic microwave background with unprecedented precision, searching for the faint swirl of polarization that would signal primordial gravitational waves. The Euclid mission, launched by the European Space Agency, will chart billions of galaxies to study dark energy, the mysterious force accelerating cosmic expansion. If dark energy is linked to the vacuum itself, it may hold clues to the universe's birth. Farther into the future, next-generation colliders may probe energies beyond the Higgs, perhaps uncovering new particles or forces that shaped the early cosmos. And space observatories may one day detect direct evidence of other universes. Signatures imprinted in the microwave background, or collisions between bubble universes in an inflationary sea. Each tool extends human reach. Each experiment sharpens knowledge. And yet, even as evidence accumulates, the paradox remains. The James Webb Space Telescope can peer into the first galaxies, but it cannot pierce the Planck epoch. Particle accelerators can probe the vacuum, but they cannot explain why the vacuum exists. Gravitational waves may reveal inflation, but they cannot answer what ignited inflation itself. Science stretches its hand into the abyss, but the abyss remains vast. For every door opened, another appears. For every echo detected, a deeper silence waits. And perhaps this is the destiny of the search, not to end the mystery, but to deepen it. Each discovery transforms the question, rather than erases it. The more we see, the more we realize how much lies beyond sight. The tools of science are not only instruments of measurement, they are instruments of wonder. They show us that the universe is stranger than myth, more intricate than philosophy, and more beautiful than imagination. Yet they also remind us that the first spark remains hidden. The James Webb Space Telescope can show us the dawn of galaxies. The Large Hadron Collider can reveal the hidden structure of the vacuum. Gravitational waves can carry the trembling of creation. Supercomputers can replay universes in digital dreams, but none can yet touch the silence at the origin. The search continues. Humanity, fragile and brief, builds machines the size of cities, mirrors the size of houses, detectors sensitive enough to hear a proton shift, all to chase a question older than history. How did the universe begin when nothing existed to ignite it? From the silence of the void to the birth of galaxies, from quantum seeds to the grand tapestry of cosmic webs, the human search for beginnings has carried us across time itself. We have mapped the afterglow of creation, traced the scattering of galaxies, simulated universes in silicon, and built machines to listen for the trembling of spacetime. Yet after all this, the first question still stands, unsilenced. How did the universe begin when nothing existed to ignite it? This is no longer just a question of physics. It is a question of meaning. For if the Big Bang was the birth of time, then before is a word without anchor. If quantum tunneling sparked creation, then probability, not reason, is our foundation. If the multiverse teems with universes, then existence itself is no longer unique. And if no cause is required, then causality itself, the very skeleton of thought, may be no more fundamental than the stars that sparkle in a night sky. Human thought is built on cause and effect. It is how we survive. Fire burns because a flame is lit. Rivers flow because rains fall. Our minds are chains of reasons, each link giving rise to another. But the cosmos whispers a different truth. Perhaps causality itself is not eternal, not fundamental, but emergent. In the same way that temperature emerges from the motion of countless atoms, causality may emerge only once the universe has space and time. The first instant may lie outside this chain entirely, a moment uncaused, requiring no ignition. This is difficult for the mind to accept. To imagine a reality without cause is to imagine a story without beginning, a flame without a match. And yet, the universe itself seems to tell us that this is the case. Nothingness terrifies. It is the absence against which we measure existence. Ancient myths softened it with gods, eternal cycles, and primeval battles. Philosophy sought to banish it with unmoved movers and first causes. Science, for centuries, tried to imagine an eternal cosmos to escape it. And still, nothingness returns, haunting the foundations of all thought. But perhaps our fear of nothing is misplaced. For the paradox is this: without nothing, existence could never be. It is the silence that makes the music possible, the blank canvas that allows the painting to appear, the emptiness of space that permits the stars to shine. Nothingness may not be the enemy of being, but its partner. Out of nothing, everything arose. Out of silence, galaxies sang. Out of absence, life awakened. There is, too, a strange comfort in a causeless universe. For if existence requires no cause, then it is absolute. It depends on nothing outside itself. It cannot be broken by reason, erased by doubt, or dissolved by the absence of a prior spark. The universe exists because it exists, and in that tautology lies a quiet awe. For it means that reality is not a puzzle to be solved, but a gift to be received. Every galaxy, every star, every life, every thought, all are the flowering of a causeless beginning. We are not suspended upon infinite chains of reasons, but upon the sheer fact of existence itself. The paradox remains unsilenced, a fire that burns without ignition, a story that begins without a page, a law that writes itself into being. But perhaps this paradox is not a failure of thought, but the deepest poetry of reality. The universe may not answer the question why, it may instead embody it. The cosmos itself is the answer. Vast, incomprehensible, luminous, silent. Philosophy once sought reasons beyond the world. Science once sought laws beyond the cosmos. But perhaps there is nothing beyond. Perhaps reality is its own reason, its own cause, its own foundation. In this light, the universe becomes not a riddle, but a wonder. The first moment is not a problem to be solved, but a mystery to be embraced. For what does this mean for us? Fragile beings adrift in one corner of the Milky Way, on a pale planet circling a small star. It means that we are children of paradox. Our bodies are made from atoms forged in stars, which in turn were formed from hydrogen born in the Big Bang, which in turn arose from the trembling of nothingness. We are the echo of absence, the flowering of silence, and in our ability to ask the question, we complete the circle. The universe became conscious of itself in us. Through our questions, the cosmos gazes back into its own beginning. Through our wonder, nothingness knows itself as being. To seek the first cause is to seek our own reflection in the abyss. Perhaps the most beautiful image is this: the universe as a silent flowering, a bloom from no soil, a flame without fuel, a breath without lungs. From nothing came time. From time came galaxies. From galaxies came stars. From stars came worlds. And from worlds came life, love, and thought. The spark required no match, yet it burns still. In every atom, in every heartbeat, in every question we dare to ask. And so, the final reflection returns us to the beginning. How did the universe begin when nothing existed to ignite it? The truest answer is that we do not know, and may never know. But in that not knowing lies a deeper truth. The question itself is the gift, for in seeking it, humanity transcends survival and enters wonder. In asking it, we become more than creatures of Earth. We become participants in the cosmos, voices in its unfolding song. The meaning of a causeless beginning is not an answer to be found, but a mystery to be lived. Imagine the first moment, not as an explosion, not as a fireball, but as a silent flowering. A bloom in the dark, with no gardener, no soil, no seed. From that bloom, space stretched wide. Stars ignited, galaxies spun, worlds awakened, and on one of those worlds, in a quiet corner of the Milky Way, beings arose who could look back into the abyss and ask the impossible question. The universe began without a cause, and yet here we are. Sparks of thought in the endless dark carried on the breath of a causeless beginning, still searching for the match that never was, and marveling at the fire that still burns.